If you've installed Unity Hub and not Unity, you may get here, and this is a list of projects that I have, totally fine. In installs, you may need to add one in order to actually have Unity, the software. So what Unity Hub does is Unity's really, one of the things that's really irritating about Unity, there are a couple, is that it releases software updates quite frequently, and it doesn't like update the software. It is a new version of the software. And so I'm already like, I chose not to. When you go to add, it will give you all of the different versions of Unity that you could possibly download. I'm a couple steps behind the last. LTS means long-term stable. Usually it is good to keep a long-term stable build on your computer. You can play with the new ones. They will release new features. It's something like 2020 probably has a bunch of new features in it. I haven't even opened it up yet. But it may also have a bunch of bugs. And so I usually grab whatever the latest long-term stable is. If it's within the last 2 or 3 months, I don't even bother updating it, to be honest. If I'm working on a project, I will absolutely not update Unity mid-projects. It's a terrible idea. Don't do it. You may break your project, you may get really unhappy, unless you're very good at doing backups. And aside, if anybody really wants to learn how to back up their projects to something like GitHub, let me know and I can walk you through that process. It tends to, GitHub is very confusing for people who don't use it, so I'm not going to make everybody do a backup of it, but it's great. It's a good idea to have a backup. You may need to add one. Once you add one, you're going to have your projects, you're going to hit new, it's going to give you some options. You just want 3D, just like leave it with the default. Again, if some of you are really familiar with Unity and you want to use one of the different pipelines, you totally can. So that's this is this high definition render pipeline and universal render pipeline. They are where Unity will end up at some point. High definition does really fancy graphics work, but is really hard on your computer and is much more complex to get into. I've only worked with it a couple times, and so if you're a person who wants to take on, wants to explore HDRP for this project, you totally can, and I will help you where I can. But some of the render pipeline, like render pipelines are a very specific thing, and they're very complex, and they can be very performance heavy. And so if you don't know how to optimize them, it's sometimes a little difficult. But if you are one of those people that is thinking, I just want to go and do really rad visuals, HDRP has a little bit more to offer you, especially if you want to get into different kinds of like complex lighting or volumetric fog or volumetric lighting, like things that are really complex computer graphics. Oh, I was hoping that it was going to like take me to a showcase, but no. I can show you some differences about how this is. We're just going to start with the default one, and that's what we're mainly going to be talking about for the entirety of it. But I have this little project, which it's already open. This is the silly project. This is welcome to Unity. Here is the Unity editor. This does a very silly, this is look at, I'm an artist. Congrats to me. But what Unity is an interactive 3D environment. It is an engine for making interactive 3D experiences. You can make 2D in Unity, but I've never really had anybody suggest it very strongly to me. There are lots of other game engines. And again, like game engines, they're called game engines, but really what they are is like interactive engines. And so they can be very interesting and are often at their most interesting when they're not in fact used for games. But really what they have is the support to combine a bunch of systems that let you do interactivity in 2D or 3D environments. And there are people, everybody I know who works in 2D generally says that there are other engines that are better for doing 2D. You can do 2D if you want. We're not going to do 2D for this module. We're going to do 3D. I don't know if you guys have, I'm gonna get rid of this because it might be a little distracting. If anybody has worked in any kind of 3D environments before, or if that's something that has been covered in any of the ateliers yet. I'm gonna assume it has not, and just assume that nobody really has a lot of 3D experience. When you open up Unity, this is what you're gonna see by default. Unity is all modular windows, so you can move everything around. I don't, oh good, no, I've made it terrible. You can resize everything. There's, oh, I've just forgotten the word for that. Anyway, you can have different panels. You will find as you go through it, the panel and layout that you like. This is my layout of choice. The central things of Unity that you're going to look at over and over and over again, depending on which areas you decide you want to focus on. Your hierarchy needs to be visible all the time. That's this little dude over here. Your scene view is your environment, not from how your camera will see it, not from how your game will be seeing it. This is just everything that is in your environment. Right now you can see that there's very little in here. Inspector is where you will get all the information about the components that you're using, and so it's very important. Those three things all the time, back and forth. You probably also want your project, which is your folder structure within the project that you're working on. If you're unlike me, this will look very organized as you go forward. If you're like me, it'll just be a folder with a bunch of stuff in it. By default, when you open it up, it gives you some other stuff too. The game window is pretty useful. The game window is what, when you are running your simulation, what will be seen through the app or through the viewer. And that is pretty much just wherever this camera is. You can see that I have a main camera component up in here, but we'll get into that. One of the base kind of ideas, one of the base things of Unity is this play functionality up here. When you hit play, it will run all your code. It'll run everything that's happening in your environment. It will run it. So if things are going to move, it'll turn on gravity. It does all the things. There is almost nothing happening. There is nothing happening in the scenes. When I hit play, you don't notice anything. But you'll notice that in my other scene, nothing happens, and then I hit play and stuff starts moving. That's kind of the base. You can pause it, but generally you stop it. A fundamental thing to remember is that you do not want to edit stuff in Unity when you are in play mode. You're going to be hopping in and out of play mode all the time to test stuff to see whether or not it's working or what it looks like. You don't want to edit in play mode because by default, Unity will not save your edits. This will happen at some point in the next 3 weeks. For those of you who are new, you will have forgotten that you have hit play. You will go to add an object. You will position this object exactly where you want it to be. It'll be perfect. You will unhit play and it will disappear. There are some components that do edit live, but most of them do not. So just if you keep losing stuff, just check on whether or not you have that play button hit. So the base ideas of Unity. Again, I'm just gonna boop. If you are familiar with Unity, this is all gonna be pretty repetitive for you. This is the thing you're gonna know quite easily, but good fundamentals. Your hierarchy lists every game object you have. Unity classifies every object that it uses as a game object. That's going to be useful to know when you're trying to script things. But so even though this says main camera, that's just a title. That can be anything. I can rename it to. It has a camera on it, but that its name means nothing. It is a game object, and every game object, if you right click in your if you right click in the hierarchy, you can go create you can create stuff. We're going to create an empty. This is an empty game object. Everything in Unity is a game object, and then every game object has components that give it behavior, that give it visuals, that give it some kind of qualities that make it unique versus all the other ones. So by default, every game object needs, you can see on the right over here, every component attached to a game object. Components will become very like recognizing everything as a game object that has a series of components on it is very useful when you're thinking about script and interactivity, because sometimes you will want to interact with the game object, sometimes you will want to interact with a specific component on it. Things like scripts are a component. Everything is going to be in this component model, and you're probably going to be referencing specific components quite frequently. Saying component over and over again at 9:44 in the morning is making me convinced that it's not a real word, but we will believe in component systems. I don't know if this happens to everybody else. When you like write something over and over again, you're like, oh, the more I've written down that word, the less I'm convinced that it's even a word. Happens to me all the time. So we have our base game object. This little check mark up here is whether or not it is on or off, like whether it is enabled. So you can just have things in your scene that are turned off that you're playing with that you don't want to be in your final build, or you don't want to be happening when you press play. This is its name. Tag and layer, you're probably not going to worry about for the next 3 weeks. Tag and layer is kind of, it's another way that you can build interactivity and connection between components. So you can group things by tag and then affect everything by tag. You can group things by layer and affect everything by layers. Unity by default uses some layers for some stuff, but you probably won't have to worry about it. And then every game object has a transform, and transforms are the position, rotation, and scale. So like it's three-dimensional qualities, like it's qualities that relate to its three-dimensional space. If you're new to 3D and this is your first time working in a 3D environment, this will be very fundamental knowledge for you. You can at any moment collapse or expand a component, and these three little dots over here mean you can reset it, and it'll just reset all of the numbers in there, which is useful because sometimes there are a number of ways to create objects in Unity, and sometimes it throws them out into the middle of nowhere, and then you will lose track of it, and sometimes you'll just need to reset it. All right, so that's a game object: transform, position, rotation, scale. So scale means nothing because this has nothing attached to it right now. It should, hopefully, at some point it'll have something attached to it. So if we look at our main camera, you will see that it has this transform, which is everything. Also, you could edit its name in here, just in case that was useful. And then it has this camera component. And the camera component is default to Unity. So you're going to be building custom components when you get into scripting later, but for the most part, especially for today, we're just going to be using built-in components. And the camera component gives you all of these different variables that affect how the camera works. Right now, it's all it can see is a skybox. So the skybox is the 3D, it's like the background to everything. It can affect your lighting. It doesn't need to affect your lighting, but it can. And all I can see is the skybox because there's nothing in here. One of the first questions you're probably going to get into is like, how do I make the skybox prettier? We'll do that on Friday. This is just like, we're trying to have a base sky. So what I'm going to do, so that we have like some reference for what we're talking about, is I'm just going to right click in the hierarchy and make a 3D object. And you have a series of base primitives. Wednesday, definitely Wednesday. I don't know why my brain has decided it's Monday and Friday. What we're going to talk about on Wednesday is how to replace your skybox. Unity has by default some base primitive 3D shapes built in that you can start to fiddle with. That is hopefully what you'll be fiddling with today when you open up and get into your own Unity projects. If you want more complex 3D shapes, you will have to take Unity. You'll have to go outside of Unity. So there's a couple different ways you can do that. There is a thing called the asset store, which we're also going to be talking about on Wednesday. If you're familiar with Blender or Maya or any 3D program, you could be making your own, but by default, we're going to start with a cube, a sphere, a capsule, a cylinder, and a plane. Quads, these ones you don't usually need to worry about. Terrain we will be talking about because you can make cool terrain within Unity. So for people who want to make like cool, expansive forests or whatever, we'll get into that, but it's a whole system. So like ignore from quad down today. I'm just gonna start with a cube. Now we have a cube. Cube, cool. Cube is like the base fundamental. You'll notice that I hit cube and my position is not in the center. I'm gonna reset it. It becomes in the center and all of a sudden you can see it in the camera. I'm gonna make this cube a floor. So I'm gonna rename it floor. And I'm going to change its scale so that it's a little bit wider and different along the X and Y axis, X and Z axis. Again, if you're new to 3D, you have this little gizmo icon up here in your 3D space. And you can change the view of your space with this. It's kind of handy. There's a number of ways. By default, you have a selector tool selected. These are your tools up at the left hand up here, which means that I can select objects in 3D space. Oh, a note for those of you on laptops, you will probably want a mouse. Unity is incredibly difficult to maneuver without a mouse with a scroll wheel or like a center button. It's hard on a trackpad. Center mouse click moves your view around only in scene view, and right click rotates your camera on axis. So center moves your you can also scroll in and out, and right click changes your viewing angle. You can also do that by clicking through these options up here, but it's much easier if you just use a mouse. The other little trick for maneuvering in your scene view, because you're going to be moving around your scene view all the time, is if you right click and are a computer gamer and comfortable with this, you can use the WASD keys to move in space. So W, I'm moving forward. E and Q are up and down for those of you that are comfortable. Controls. I can't game. And the only times that I can PC game are because I learned how to use WASD for Unity. Yes, so those are quick notes about maneuvering in your scene view. They are very useful. I'm going to set, and if you ever are, sorry, that started with, are confused about what axis you want something to move along or grow along, or once you get into scripting, which one is the important one for whatever script you're doing, you can always see it up here. Y is up and down, and X and Z are forward and backward and left and right, but sometimes those can be very hard to orientate yourself around. But if you click on any of these little pyramids, it will adjust your view directly along one of those axes. You can still then mess it up, but if you want a top-down view, you can click that. If you want to look at everything from the side, this is very useful. If you click perspective, it will change it to isometric, which I don't recommend because isometric is very confusing. It looks really pretty, but this isn't your game camera. This is just your scene view camera. And isometric cameras look cool when you use them in your game, but are very confusing for navigating your scene view. Oh, apologies. Warnings. All right, so we have our floor. We want to make it into an actual floor. So I'm going to extend it along the X and Z axis so that it pulls out. You can tab through variables here, and you see that now we have a floor. Great, good. I made a virtual environment in Unity. Course done. And by default, so there's a couple systems we're going to talk about today. Mainly, you need to understand that there's primitives, there's 3D spaces, and then there is these things called colliders. Colliders are, by default, when you make a 3D primitive in Unity, it will come with the cube, the mesh renderer, and a box collider and a material. And these are the base kind of building blocks of all 3D objects in Unity. If you want something to have any kind of physical presence or visual presence, you will need these elements. The mesh is its actual like 3D geometry. You don't usually need to touch that unless you're getting into more complex three-dimensional shapes. But you probably won't have to worry about that for these next 3 weeks. The mesh renderer is how things look and how it interacts with the materials and all that kind of stuff. You probably also will not need to touch this for the next 3 weeks. All you need to know is that this links it up to this material. And we're going to talk about materials on Wednesday because that is how things are given visual qualities. But the mesh renderer hooks up the shape to the material that it's pretty much like folding over the three-dimensional shape. And then the box collider. This is a cube, therefore it is box shape, therefore it has a box collider. There are different kinds of colliders. Colliders are probably, I would say, one of the, as a person, I work a lot in physics in Unity because I like physics-based interactions, and because I come from VR, or I work often in VR, I like physical interactions. And so a lot of what I do is relative to colliders and the properties of colliders. Now, colliders are the thing that determines the behavior of the bounds of the mesh and how it relates to other things in the scene. So the mesh renderer gives it a look, the collider gives it some kind of physicality, or determines what its physicality is going to be. And that might be that it doesn't have any physicality, which we'll talk about in like 2 seconds. If you are confused about the rest of your windows, poke me. The console, we're not going to get into today, but it'll be very useful at a later date. So for your first little bit, if you want to just like move something over to off your console, go nuts. I'm going to make a second box so we can talk about a little bit about the difference between box colliders. Or maybe I won't make a box. Let's make a sphere so you can have a different collider. Great, it put it in a weird place again. I'm just going to reset that, and then I'm going to pull this. You can grab any of these arrows. The quick keys for Unity are not Q. QE. There's Q. WER. Is that really all we use? Yes, WER. Describing quick keys when you just like use them. So W is your movement, E is your rotation, and R is your scale. Right, so that relates directly to the 3 parts of the transform. By default, we are in our, again, this is up here too, our move tool. And in your move tool, you can grab any of the arrows or any of the planes, right? So if I grab this arrow, it will only move along the x-axis. If I grab the plane, it will move along the x and z axis. So we can position this somewhere that it's visible by the camera, and then we can make it bigger if we want. There's no point in rotating it, it's a sphere. Same goes here. You can pull along an axis, which looks real weird, or you can grab the middle and make it a different shape. You can also do this directly through inputting numbers in the transform component. It exists. Great, good. Right now, when I hit play, nothing happens. Nothing is going to happen. These 2 objects are just hanging out in space. They have colliders on them. They have mesh renderers. They have a default material, which is very boring looking, but they're doing literally nothing. We've given them no behavior whatsoever. Let's just for fun. If you right click in the hierarchy, you create things in your project, in your scene, right? So you're creating an object that's going to go in your scene view. It's going to be, and there's scenes, you can have many, many scenes within a game. You can think of them kind of like levels. If you're making some weird, cool GIFs or some like visual environments, you can think of them as like the independent projects, like what one visual would be. In your project folder, if you right click and you create, it's in your project. So it's a file or a folder, like a file that can be referenced within your project, but it's not in your scene yet. So I hate this like default beigey situation. And we'll talk a little bit more about materials, but I'm going to make a new material. And we're going to make it a cool color because like who doesn't love cool colors? That was a very simple way of making something look a little different. You just make a material and then you drag it onto it. And when you click this, you'll notice that the material down here is now changed to pink. That's like the basics. We don't even need to talk about materials that much more, but we probably will a little bit on Wednesday. Okay, so we have these objects. They're pink now. It's a little bit more fun. But they do nothing. And what the properties of the colliders that are on them won't be apparent until they actually, in fact, do something, until they have some kind of behavior added to them. And the way that we're going to do that is through a rigid body. Now, when you want to add a component, I'm going to do that again. When you want to add a component to a game object, there are a couple ways you can do that. If it's in your project, you can drag it over. And once you get that little arrow pop out, right, like it'll add to it. I don't need to add that to it. Or you can just hit this add component button that is in every game object. In add component is all of the components that are built into Unity and that are available in your project. You can start typing and it will autofill. So I know that I'm looking for a rigid body. I know I'm not working in 2D. I want a 3D rigid body, and now I clicked it and it is added. The rigid body is the way in which the object gets linked in to Unity's physics system, right? So there's a physics system in Unity. Sometimes it behaves like the physics system in the real world, and sometimes it does not even a little bit, and it is very confusing for everyone involved. It is a simulated physics system. A lot of people in the world would probably fight about the values of Unity's physics system versus something like Unreal's physics system. It's weird, and expect some weird things to show up when you're starting to use it. But in order for your object to relate to the physics system, it needs rigid bodies and colliders. Those are kind of the ways that it does it. But the rigid body determines the qualities, like the physics qualities of the object. One of those things is whether or not it links into gravity. So there is a default gravity system in Unity. I wouldn't recommend editing it, but you can if you really want to. And the things that you really want to pay attention to when you're starting out in Unity in this rigid body is use gravity and is kinematic. Those are the two variables that are relative and relevant for beginning things. You don't need to worry about mass drag, angular drag. Those are more complex physics interactive variables, and it's not important. But you'll notice, I'm just going to move my camera out. Click my camera, move it out a little bit, move it up. You could change the field of view. You can get into like nerdy camera things, which I do. No need at this current moment. But so we have our sphere. We've put a rigid body on our sphere now, and it has use gravity by default is checked. So when I hit play, it's going to do a thing, which is drop. Look, great, good. It's going to drop and it stops when it hits the floor. And the reason it stops when it hits the floor is because both of those objects have colliders on them. If I go into my floor and I check off this collider, so this has no active collider now, and I hit play again, it's going to fall right through it. Because although it appears to have solidity to its exterior, it does not because the collider is not active. And right away, you can see how a combination of rigid bodies and colliders could make some interesting interactions. You could make a Rube, like this is the point at which you could make a Rube Goldberg machine using just these systems within Unity. So if I make another little cube and I put it in here, and I put it underneath this guy, and I hit play, it has a box collider. It's not going to move, but it's going to move the ball. It's going to obstruct its pathway. it floats in space because, again, it doesn't have a rigid body, so it's not relating to gravity. If I give this little cube a rigid body and it's going to gravity, they're both going to fall. The other quality here is kinematic. And what is kinematic means is that it won't fall, it won't move unless affected by something else. So if I hit play, boop, it won't move except by script, which is like a little confusing that you would have both use gravity and is kinematic, and then it doesn't in fact use gravity in that moment. But what that means is that in the back end, when you start to script behaviors for how these things move through space, you can access gravity systems. Pretty sure this is going to be exactly the same. Yep. And then if you turn off use gravity and you turn off is kinematic, then it's going to do a different thing. It's not using gravity, it's floating back up, but it is in fact using force, right? It's still using a physics thing, a physics system. It's just only impacted by other things, and it's just going to float around in space. So already you can kind of like get an idea of how these systems can be used together to make somewhat like, you could make a whole lot of complex interactions happening just by using colliders and rigid bodies. Okay, so box colliders, rigid bodies. The other element to be aware of box colliders is that is trigger variable. So as we know, when we have a rigid body, when we have a box collider, we can choose how things respond to gravity. We can choose a little bit how they respond to one another. The is trigger option on colliders is similar. So if I take this box and I hit is trigger and I hit play, it's going to move right through. Well, I left gravity on. Good. Yeah. Turn off gravity. It's going to move right through it as if it's not there, which is different, you'll notice, than if it is kinematic. Right? Because when it's kinematic, that block won't move unless accessed by script or something else telling it to move. When it is a trigger, what that means is that the bounds of that mesh, the bounds of that object, are still there, but they are, it's like an area that something can pass through, but the moment that it passes through the bounds of that object is detected, and that is something that you can reference in script. So if you want to make things like, the really simple one is always like, if a player walks into a room and the light turns on, you would have a cube in the doorway that detected when the player moved through it. Now that cube isn't going to have any physical ramifications. It's not going to stop the player from moving through the doorway, but you will be able to detect the second that the collider on the player steps into the doorway and then respond to it in your interactivity. It's kind of like the base way that you will start designing some interactivity, or at least for me it was, and it's a very helpful, like it's a very powerful. You can make things quite complex just by having a series of triggers. You can hit is trigger and you can turn off the mesh renderer. You can even delete the mesh renderer if this is what you're going to do. And you'll see that that box is no longer visible in my game view, but it is in my scene view. And the sphere still goes directly through it. So it's a transparent, it's just an area that you can detect when things are in, or when they enter, when they leave, or when they're overlapping with. By default, it is confusing sometimes if that gets clicked on and then something doesn't move properly. Just as a note, you may not need that until you get into your scripting, but it's there. Those are the base defaults. So the things that you really want to start, that you want to like wrap your head around if this is new to you, is that everything is a game object. Game objects are a series of components. Those components give them behavior and different kind of physical qualities and all kinds of characteristics. And box colliders and rigid bodies is how you get everything in 3D space to interact with the physics engine and physics reactions. The next thing that you're probably going to want to get into is how to make things look good. So we're just going to steal a couple things from Wednesday because I feel like you can handle it. The big one being materials. I covered a little bit how you just make a material. So you right click, you go create material. This material can be anything. Materials have a shader on them. We are not in any way, shape, or form going to be getting into shaders in 3 weeks. Shaders are witchcraft, and I am boggled by them. So I am not the person to teach you shaders. It is a whole area of expertise. They are cool as hell. By default, we will use the standard shader. You can absolutely use shaders if you know them. I am in awe already. I will show you how to, like, you can use shaders that are assets. Like some people have already written shaders. That's often what I do. There are a couple shaders that we will use with. Yes, please do that. Please use your own shader stuff. I don't. It's a whole other can of worms. The standard shader will work for most of what you're probably going to be doing. The skybox shader is how it will affect the skybox, and then there's other shaders that are sometimes dependent on what platform you're going to be putting your projects on. So specific mobile shaders or VR shaders or whatever. But the shaders affect what the I don't even like the visuals actually look like what the skin actual behaviors of the skin of your mesh. So you can make very cool visual effects out of shaders. By default, probably what you're going to want to do is like change the color though, right? So you can make it like opaque or cutout or whatever, but mainly you just want to make things cool colors, or at least I want to make things cool colors. And so there, Unity says trans rights. The rest of these qualities are going to change things based on how they will affect how the skins of the meshes respond to light, which is something that we'll get into. Lighting can be very simple or can be very complex in Unity, especially if you get into those more difficult render pipelines. So metallic and smoothness often are about the surface qualities and how they react to light. Normal maps, height maps, occlusion and detail maps are all parts of how you will give it the appearance of texture. Emission is a whole lighting thing that I think is super cool and never works how I want it to. It requires using some baked lighting often. It's how you would make it's how you make objects kind of react like they're lights, right? So the big one that everybody wants is like, how do I make a neon sign? And you will do that with your emissions. They don't always appear how you want them to, depending on the lighting qualities of the rest of your scene. Is the thing to notice about emissions. So you will see that this one is now, it looks emissive, it's lighting stuff up. A note, you can make it in here, right? You made this blue, and then we can change all its qualities here. We can drag it onto objects from here, or we can start to edit its qualities in this component menu of our game object. The thing to remember is that if you are editing these qualities, you are editing the actual material, right? And the material is the file that links to things like a texture and a shader. A texture is a normal 2D element. So if you want to put a picture on a plane, if you want to make a picture frame or whatever, that is a texture. And the shader and the material will pull the texture onto it and then give it a bunch of qualities. But this color, so if it now looks lighter, like it looks a little bit like maybe it has some light qualities within it. But you will notice it is not lighting the areas around it. And that's the thing about emission, is that you have to get into specific lighting settings to have the light actually affect it elsewhere. Something that I'm probably going to add, to the aesthetic tools conversation on Wednesday is something called the post-processing stack. Show of hands, how can I like, I don't know. I feel in my experience, people are usually more interested in aesthetic tools than other tools. So I wish there was like an easy way to do a poll in Teams, but my understanding is that there is not an easy way to do a poll in Teams. So I'm just gonna like throw aesthetics and into the chat, and you guys can just like stuff based on which one you're more interested in or whatever. But post-processing stack is how you apply a bunch of visual imaging effects to your scene. And so you can think of them a little bit like anybody who has any experience doing image editing or video or photo, like some of those filterings. So if you want to add grain or you want to color correct or you want to do all that stuff on the camera, the post-processing stack is a tool that lets you do that. I love it, obviously, because of my own background, but also it just makes things look really pretty and makes things look a little bit polished. So you can do things like shallow, like your depth of field and having cool blur kicking around. You can do chromatic aberration, which is, they're all things that like, a lot of them are things that you shouldn't do if you're doing VR. But since we're not doing VR, we can talk a little bit about the post-processing stack on Wednesday when we talk about aesthetic tools. But yes, this is how you change the color of objects. Generally, it's good for differentiating things, even if you're not that interested in making stuff look pretty. The one specific type of material that we will talk about is a skybox. And skybox are, yes, you can totally do VR if you have access to VR in your home. A lot of if you are interested in VR, a lot of the tools in Unity that we will be using are transferable to VR. The main difference is that the thing that VR does differently than normal is the camera. You need a VR camera element in your scene to actually have VR function properly. And depending on which VR system you are using, you will need a different integration package. So if you have an Oculus Quest or an Oculus Rift, you'll need the Oculus integration package. If you are on a Vive or one of the other ones, whatever the Index, all the other bazillions of ones, then you have to go through Steam VR, which hopefully is better than the last time I used it. It's the worst. Steam VR is really a nightmare to work with. And so if you ever want to, if you're like, oh, I'd love to make VR, I don't know which system to buy. One, Oculus is significantly cheaper than the Vive. Two, it's significantly easier to work with their software. Three, they are owned by Facebook and mega evil though, so you win some, you lose some. Not that necessarily the other ones aren't evil, we just don't know how to track their direct evilness based on their proximity to Facebook. I use Oculus because it is what I was taught on, and that was before they were owned, and now I feel conflicted about it every time I make a VR or even play a VR. Also, if you want room scale or whatever, if you're interested in VR, if like people are interested in VR and they want to have longer conversations about VR, I am around for that. The main thing is just that camera component, and everything else will be transferable skills. Ooh. Okay, so that's visuals, that's some rigid bodies, that's some weirds, that's some component systems, you got some elements. The only other thing that you're gonna worry about is Skybox. Because for me, it's like I don't even like working in the default Skybox. I find this like so uninspiring and everything just looks like I find it upsetting to even have to work with a normal Skybox. And so Skyboxes, you just go create material and then you make sure that in the shader, the type is Skybox. And then you can add, and what it is that it's a cube map. And so it's going to take 6 images and wrap them around in the appearance of a cylindrical environment. So I'm going to delete this. And then you will have your lighting panel. You probably won't have your lighting panel by default. And we won't get into we will not get into light mapping settings. These things are fine by default unless you really need to get into baked settings because you're doing something really complex. But what is useful in lighting, and a note, window, rendering, lighting. All of the windows that I talk about, if they are not present when you open up your copy of Unity, you can find them under window. They'll be in here somewhere. Rendering, lighting settings, and then it'll have your skybox in here. And so if you make your own skybox like I did, which is just, you can see it, it is the same image 6 times. And then Unity aligns it like this. It's the same square image. And then you just drag a different skybox in there. And you're like, great. Now I have a cool working environment where I can feel like I'm actually in a neato 3D space. This one's not always super helpful. And your skybox will affect how everything looks in your actual game view also. The one component that I didn't touch is this directional light. So every scene starts with a main camera and a directional light. Your directional light is kind of like your sunlight. It's just a huge light source that affects every single thing in your scene from a certain direction. So if you hit E to rotate it, you can see those shadows moving around as I rotate it. If I point it up, obviously, it's not going to hit that. Often the first thing I do when I start a scene is delete the directional art and start putting in my own light. You can change the color of it if you really want to. Oh, it's getting mad. Look at how mad it is. I used green on all these things. But again, that will taint everything everything in your scene. So I don't usually recommend changing the color unless you're trying to make something outdoors or indoors. So you want like a warm or cool generic light, but and you can make it really strong or dim it down. If you're somebody who wants to get into cool lighting, probably you'll dim that down. But for your working environment, you can just leave it however it is and start fiddling around with moving stuff around. A very important little like UI thing is that I keep clicking and dragging into these boxes. Any box that has this little circle, you can click it and it will show you everything that is a compatible type that you have accessible in your project. So these, because they're materials, it will let me put blue on here, but it's not actually displaying properly because it's not a skybox, right? None of these are actually displaying properly, but I can just go back to the default one here. But that goes for every component in your inspector also, is that every time something wants some kind of like link to a different type of object, you can click this little guy. All right. Intro to Unity. Done.